Alright, so as I said before, constant velocity equation, v equals delta x over t, so that's velocity equals displacement or distance over time. And this should not be with velocity, it should be with acceleration. Alright, so there are 4 of these. First one is delta x equals 1/2 final velocity, which is vf, plus initial velocity, which is vo, times t. Next one, delta x equals vot plus 1/2 at squared, so that's acceleration times time. I'll write down what all the variables mean over here in a second. Third one, vf equals vo plus at. And last one, vf squared equals vo squared plus 2a delta x. So we just have v, that's velocity, and that's for the constant velocity part. T is time. It's measured in meters per second. Time is measured in seconds. Delta x, distance or displacement. Measured in meters. Vf, final velocity. Measured in meters per second. Vo, initial velocity. Also measured in meters per second. A equals acceleration measured in meters per second squared. Alright. Do you guys have any questions about those equations? I'm going to pause it. Let's try it. These problems are going to start pretty easy, and they're going to get more difficult as we go on here. Alright, so number 1, a shopping cart is given an initial velocity of 4 meters per second and undergoes constant acceleration. I'm going to slide this over a little bit so we can see the constant acceleration of 6 meters per second squared. For whatever reason, this program doesn't give me superscripts, so you're just going to look at it like that. What is the magnitude of the car's displacement after the first 4 seconds of its motion? Alright, so let's write down what we know here. What do we know? Garrett.
The initial velocity is 4 meters per second.
That was amazing, Garrett. Alright, so our initial velocity is 4 meters per second. What else do we know?
Acceleration is 6 meters per second.
Yep, so A equals 6 meters per second squared, 6.0. And what else do we know here? Time is 4 seconds. And what are we trying to find? Displacement or delta x. Alright, do we have an equation that has all 4 of those things in it? Equation 2. And what's that equation, Garrett?
Delta x equals the initial velocity, or I guess v sub o, plus 1/2 times a times p squared.
Yep, so delta x equals VOT plus 1/2 AT squared. So now all I have to do for this one is substitute in what we know. We're looking for delta x still. We have VO is 4.0 meters per second times time is 4.0 seconds plus 1/2 times 6 meters per second squared times 4.0 seconds quantity squared. If you guys want to get your calculator out and tell me what that equals. Okay, so we got our answer is, is 64 meters. So, you guys have any questions on that one? Jake?
Why
make sense.
But then how does the second part work?
Alright, so the question was, how does the second part work? The answer is calculus. You haven't learned the calculus to figure it out yet. You are going to learn it. You guys are all in AP Calc, right? Nope. Well, if you're in any calc, you'll learn it. It's the integral. Problem here. A hiker travels south along a straight path for 1.4 hours with an average speed of 3.1 kilometers per hour, then travels north for 1.8 hours with an average speed of 4.1 kilometers per hour. What is the hiker's displacement for the trip? So this is a problem that we're going to want to break into two parts. But first, we want to think about, is there any acceleration in this problem really at all other than when they change direction, which we're assuming happens really instantaneously. Alright, so we're going to have part 1 is when they are traveling north or south, and part 2 is when they are traveling north. So, do we want to make north or south positive? North positive? Alright. Alright, so for part 1, we're going to use v equals delta x over t. So our velocity, when we're going south, since south is negative, is going to be negative 3.1 kilometers per hour equals delta x over 1.4 hours. Our units match, so we don't need to convert it all. So what does delta x equal for part 1? Negative 4.34 kilometers. And that is negative 4.34. Because we chose north as our positive direction, we're going to say negative 4.34 kilometers north, which is the same as saying 4.34 kilometers south. Everybody understand that? Alright, part 2. Still no acceleration, so we can use the same equation. V equals delta x over t. This time our velocity is going to be positive since it's north, equals delta x over 1.8 hours. That's a terrible 8. There we go. And what does delta x equal for that part? Anybody? Thank you. Alright, so now to get our final answer, we're going to add these two north directions together, even though one's negative. So we're technically going to subtract, I guess. So we're going to say 7.38 kilometers north minus 4.34 kilometers north. And what's our final answer? 3.04 kilometers north. Alright, any questions on that one? Alright, problem number 3. Car accelerates from rest at a rate of 2.6 meters per second squared for 15.6 seconds. The car then slams on the brakes and decelerates at a rate of 5.2 meters per second squared until it comes to a stop. What is the total displacement of the car? Alright, so what are we going to have to do here? How many parts are there to this problem, do you think? 2. What are the 2 parts? Acceleration and deceleration. Alright, so let's break it down like that. So we got the acceleration part. I should have the writing thing. And decel. Alright, for the acceleration part, what do we know? So acceleration is 2.6 meters per second squared. What else do we know? Yep, so time is equal to 15.6 seconds. What else do we know? Initial velocity is 0. Alright, what do we know about the deceleration part? Garrett? Negative 5.2 meters per second is our acceleration. What else do we know? Final velocity is 0. And that's all we know for the deceleration part. Alright, so we're going to want to find the displacement for both of these and add them together, right? Alright, what equation can we use to find the displacement for the first part? Yep. So it's going to be delta x equals VOT plus 1/2 AT squared. So we get that whole thing cancels out to 0 plus 1/2 times 2.6 times 15.6 quantity squared. And what do we get for delta x? 316.37, we'll say, meters. Alright. Any questions on how we got that? I'm going to shrink that, move it up to there. Can you guys still see that? Yeah, good enough. Alright. Oh, I shrank the deceleration too. Oh well. Alright. Can we figure out delta x for deceleration? All the equations we have 4 variables in them. We only know 2 things. Is it possible for us to figure out the deceleration part with what we have right now? Alright, what about part 1 is going to be related to part 2? The final velocity from part 1 is going to equal the initial velocity for part 2. Does that make sense, everybody? So let's find VF for part 1. Let's say VF equals VO plus AT. And you can use multiple different equations for this one. I would suggest using this one. The other ones have delta x in them. If you use the one that has delta x, if you messed up this delta x, if you messed up the first equation, then you'll mess up the next equation. So if you have a choice, use an equation that doesn't use something else you solved for, but use something else you were given. That makes sense, everybody? Alright. So VO is 0 plus 2.6 times 15.6 seconds. And what does VF equal? 40.56 meters per second. Alright. So we can take that. I'm going to shrink that down too. And that becomes our VO for over here. So VO equals 40.56 meters per second. I'll shrink that down to be, that's what I want to do. That'll work. Alright. So now we're going to use what we have up here to find the delta x for the deceleration part, the displacement for the deceleration part. So we're looking for delta x. What equation has acceleration, final velocity, initial velocity, and delta x? 4. So we're going to say VF squared equals VO squared plus 2a delta x. So VF is 0. VO is 40.56 quantity squared plus 2 times negative 5.2 meters per second squared times delta x, which is what we're looking for. So when we solve that for delta x, what do we end up with? I'm going to pause it with you. So when you do the math of this, you get delta x equals 158 meters. So I get our final answer. We just add those together. So we do 316.37 plus 158 And what's our final answer here? What is it? 474. Point something. 475 then. Alright. Any questions about that one? Alright. A runner runs, accelerates. I'll cross that off. West at a rate of 0.5 meters per second squared. Then turns back to the same spot at a constant velocity of 8.9 meters per second. The whole trip takes 37.41 seconds. What distance did the runner travel? Assume she accelerated instantly to 8.9 seconds on the, or 8.9 meters per second squared on the way back. Make sense? So she runs. She runs that way, accelerating, and then goes back at a constant velocity of 8.9. So, okay. So this is part one. Part two. Sorry, I lost my train of thought. We just assume she accelerates to 8.9 instantly. Otherwise, we'd have to factor in that acceleration, which would make our lives fairly miserable. So we're just going to ignore that for now. All right. So we'll break it down to two parts. We got part one. Actually, we're going to do three parts. Part one, part two, and overall. All right. What do we know about part one? Garrett?
Accelerates at 0.5 meters per second.
Yep. And it doesn't say this, but we assume she's starting a race, so VO, we need to change that. VO equals 0 meters per second. All right. What do you know about part two? Garrett? Yep, so we can just say, we're just going to say it's constant velocity, so we're going to say V equals 8.9 meters per second. When we use V without a subscript, just take that to mean that it's constant velocity, so it's the same everywhere. Yes, Adam? Why is the initial velocity 0 in the first part? Because I forgot to put the initial velocity was 0. We can't do it if we don't know the initial velocity. Alright. So overall, we know that the overall time is 37.41 seconds. Alright, with any of our equations, can we make progress in any of these parts? No. Which means we're going to have to set up an equality with other stuff we know. So what do we know about the time?
Parts 1 and part 2 add up to equal 3.
Yep. So overall, time for part 1 plus time for part 2 equals 37.41 seconds. What else do we know? Jake?
That delta x for part 1 is the same as delta x for part 2.
Delta x for part 1 equals delta x for part 2. Those things make sense to everybody? Those two equations? Alright. Let me shrink this down a little bit. Alright. So we can start with either of these. You're usually better off starting with delta x ones because a lot of our equations work well with delta x. Like we have a couple of equations solved for delta x. We don't have any equations solved for time. So we're going to say delta x 1 equals delta x 2. What's an equation we can use for delta x1 that has acceleration and initial velocity would be preferable, and time, since we have an equation for time as well. Equation 2. So we're going to say delta x equals VO t plus 1/2 a t squared, and those are time ones. For part 2, we're at constant velocity, so we're going to use the constant velocity equation that v equals delta x over t. Solving for delta x, we'd get the velocity times time 2 equals equal to delta x2. Any questions on how I got to this equation? Alright. So let's plug some numbers in. We get 0 for that whole thing, plus 1/2 times 0.5 times t1 squared plus, equals 8.9 times t2. So we have two unknowns here, but we have this lovely equation that has both of them. Do we want to solve for t1 or t2? Doesn't really matter. Let's solve for everything in terms. Let's solve this equation in terms of t1, so we don't have to square what we solve for. So that would be t2 equals 37.41 minus t1. So we get 1/2 times 0.5 times t1 squared equals 8.9 times 37.41 minus t1. And what are we going to have to do to solve that eventually? Can you guys see it already? Quadratic formula, everyone's favorite. Hopefully you have it on your calculator. If you don't, you'll be sad. That's getting a little small. Alright. So let's rearrange this a little bit. I'm going to bring everything over to the left side here. So we get 0.25 times t1 plus 8.9 t1 minus, what's 8.9 times 37.41? Or 332.95 equals 0. Alright, so somebody with a quadratic formula in the calculator, tell me what t1 equals. Like I said, we forgot this to be squared. Squared. And our time, we're only going to use the positive one. So it's 22.8 seconds. So now, how can we go back and figure out using t1, figure out how far she ran? We could find t2 and do velocity times time, or we can do it with, since delta x1 equals delta x2, delta x1 is going to be equal to VOT plus 1/2 AT squared, and that's t1, and t1, so that equals 0 plus 1/2 times 0.5 times 22.8 seconds squared. Delta x1 equals what then? $129. So 129.96 or 130 if you prefer meters. Alright, so that's our answer. You guys have any questions over that one or any other one we've gone over so far? Go. Thank you. Times 2. So that's delta x1. It asks for the total distance. So it's going to be that times 2, so 260 meters. Alright, so now any questions? Jake? Just say 0 if it asks for the displacement.